We are covering the hydrologic cycle and the rational method for the FE civil exam, a topic you will find in the Water Resources and Environmental Engineering section of the NCEES specification. The hydrologic cycle describes how water moves, including precipitation, infiltration into the ground, and the resulting runoff, which is our focus. The rational method is a fundamental formula used to calculate the peak runoff from a small watershed, typically under 200 acres. This formula, Q equals CiA, is located in the Hydrology and Water Resources subsection of the Civil Engineering chapter in your NCEES FE reference handbook. Let's break it down from an exam perspective. Q represents the peak runoff rate in cubic feet per second, or CFS. The units are the first major trap. The formula is an empirical relationship where the units don't intuitively cancel, so you must use the specified units for it to work. The C is the runoff coefficient, a dimensionless number between 0 and 1 that represents the fraction of rainfall that becomes runoff. For example, a paved surface like asphalt has a high C value, around 0.95, because most rain runs off. A grassy field has a low C value, maybe 0.1 to 0.2, as most water infiltrates. A very common exam problem involves a composite area. You might be given a 20-acre lot that is 50% pavement with a C of 0.9 and 50% grass with a C of 0.2. You must calculate a weighted average C value. You would calculate this as 0.50 times 0.9 plus 0.50 times 0.2, which equals 0.45 plus 0.10 for a weighted C of 0.55. Next is I, the rainfall intensity in inches per hour. This is another huge exam trap. Do not confuse intensity with the total rainfall depth. Intensity is a rate, and you find it using a designed storm frequency, like a 10-year or 25-year storm, and a specific duration. That duration is the time of concentration, or TC. The time of concentration is the time it takes for water to flow from the most hydraulically distant point of the watershed to the outlet. You will use this TC value as the duration on an intensity duration frequency, or IDF, curve provided in the problem to find the correct I value. Finally, A is the drainage area in acres. This is the most common mistake test takers make. The problem may give you the area in square feet or square miles, and you absolutely must convert it to acres before using the formula. Remember that 1 acre is 43,560 square feet. Let's walk through a typical problem. A 15-acre watershed has a weighted C value of 0.6. The time of concentration is calculated to be 20 minutes. The problem provides an IDF curve, and for a 20-minute duration storm, the rainfall intensity I is 4.0 inches per hour. Now, apply the formula. Q equals 0.6 times 4.0 inches per hour times 15 acres. This gives you a peak runoff of 36 cubic feet per second. The key is plugging in the variables with the correct units. To help you remember the formula and its tricky units, use this mnemonic. Think of the CiA, but for floods. And for the units, remember the phrase, crazy inconsistent acres. To remind you that C is unitless, I is in inches per hour, and A must be in acres to get the correct answer in CFS. For free practice questions, AI-powered explanations, and more exam prep tools, visit openexamprep.com. That's openexamprep, all one word, .com.